Willamette Valley, a land intertwined with creeks and rivers that have supported First Peoples for thousands of years. During the 19th century, these waters and their resources drew non-native settlers such as fur trappers and missionaries who would later use this significant resource for irrigation, transportation, and manufacturing. At the Willamette Heritage Center, we care for two of the oldest framed houses in the Pacific Northwest. These houses were constructed by Methodist missionaries in 1841 who utilized the raw power from Salem's Mill Creek to power a lumber mill. As more non-native settlers arrived, the need for reliable water grew. In 1857, a man-made canal known as the Salem Ditch was completed to divert water from the North Santiam River in Stayton to Mill Creek in Salem. The consistency of year-round water flow allowed many mills and other businesses to power their operations. One such mill is our own Thomas K. Woolen Mill. Established in 1889, the mill used water to mechanically power a 4-story building filled with belt-driven machinery. The power was generated from our mill race, employing a 12-foot decline of water flowing through a 1914 LaFell-Sampson 45 water turbine, which produced 170 horsepower. Using a series of gears, the turbine would turn a shaft, which would then power machinery using leather belts and pulleys, as seen here in our machine shop. A turbine is a type of water wheel that spins when water flows through a series of paddles or blades. In the case of the Thomas K. Woolen Mill, our turbine converts the kinetic energy of flowing water into mechanical energy that turns the belts that operate the machinery. Water wheels are quite simple machines and can easily be built at home. Let's build one together. To construct your water wheel, you will need one plastic cup, duct tape, one pencil, a pair of scissors, 1 to 2 feet of string or yarn, and a handful of paper clips. Use a marker to mark out 2 triangles on the opposite sides of your plastic cup. This will be a guide to help you cut out each of these triangles. This will create a groove for you to place your pencil. This pencil will act as the axle of your water wheel. Let's create the paddles of your water wheel. For this, you will need 2 long pieces of duct tape, 3 to 4 inches in length, and 2 short pieces of duct tape, 2 to 3 inches in length. Place the pencil in the middle of one of the pieces of duct tape and sandwich it with the other. These will create the first 2 paddles of your water wheel. Next, take the shorter pieces of duct tape to create your other 2 paddles. Place them on opposite sides of the pencil. Does your pencil look like this? Great job! Now it's time to trim the paddles of your water wheel. Take your scissors and trim each paddle. Test your water wheel inside the cup to make sure it spins freely. Now it's time to test your water wheel. Place your water wheel inside the cup, resting it in the triangles you cut out earlier. Pour some water over the top of your water wheel. Does it spin? Great job! Let's harness the water power from your water wheel. For this, you will need your 1 to 2 feet of string and a small strip of duct tape. Use the duct tape to attach the string to one end of the pencil. When your water wheel spins, it'll wind the string along the pencil. This is mechanical energy in action. Take your paper clips and attach it to the opposite end of the string. Our goal is to spin the string along the axle to pull the weight of the paper clips up. Pour water over the top of your water wheel. Did you pull the paper clips up? Great job! To learn more about Waterpower and the history of the Mid-Willamette Valley, visit us in Salem, open Tuesdays through Saturdays, 10 a.m. to 4 p.m., or on our website at www.willametteheritage.org.